Section 10.2, we're going to solve quadratic equations in a different way. We've solved them by factoring and the square root property and completing the square. 3 methods isn't enough. You need 4, at least 4. So we're going to give you one last one. It's for solving any quadratic equation that can be written in this form. If you can write it in this form, then you can solve it with the quadratic formula. So what is the quadratic formula? How does it work? Well, the actual proof of the quadratic formula comes from completing the square, the stuff that we did in section 10.1. Now, I'm not really going to spend a lot of time on this, but I will show you what goes on with the quadratic formula, how it's derived. You start with the general equation that I wrote out. Then you need to make the coefficient of x squared 1, so you divide everything through by a. We'll move this term to the other side, and we're going to complete the square on this term. Now, do you remember what we did when we were completing the square? You took half of this coefficient, and then you squared it. So half of that is b over 2a. When you square it, you get this. We add that to both sides. The left-hand side is now a perfect square. The right-hand side, you get common denominators. Take the square root, and eventually you get down to this, down at the bottom, right here. So that's the formula that you're going to need to know. You can start taking your notes by writing down this formula, and then do yourself a favor and make sure you have it memorized. Not only for this next test, but for the final exam. Negative b plus or minus the square root of b squared minus 4ac over 2a. So, do you want to know one of the questions on your next test? Yeah. What's the quadratic formula? Just write it down. So here's 2 free points. I'm telling you this up front. It'll be there. I'll also ask you to write on the final exam. Now, where you use it is up to you. You don't necessarily have to use it on every quadratic equation. In fact, let's start out with the following example. Suppose I had x squared minus x minus 12 equals 0. I was asked to solve this, and for whatever reason I decided, you know what, let's use the quadratic formula. To use the quadratic formula, it helps me to identify what a, b, and c are. So a, b, and c are the coefficients. You're not going to be plugging in the values of x or y or anything like that. They're just the number parts here. Now some of these aren't really written, but they're understood. So we'll see if we can't figure them out. There's a 1 that's understood to be here, a negative 1 that's understood to be here, and c is negative 12. So 1, negative 1, and negative 12. This is a good one to kind of start out with because the numbers will eventually work out pretty nice, but it's also a good warning. You have to be careful when you plug this stuff in. What I suggest, and what I often do, is write the quadratic formula with parentheses where the a, b, and c go. So that is x is negative of something plus or minus something squared minus 4 times something over 2 times something. The reason for that is because, especially when you have negative numbers like you do for b and c, it's very easy to miss a double negative, like right here. The negative of negative 1. Plus or minus negative 1 squared. Minus 4 times a, which is 1, times c, which is negative 12. So there's a lot of care that we need to put into taking, cleaning up all these negatives. The double negative here becomes a positive. Square root of negative 1 squared. Well, what do I get when I square negative 1? 1. In the denominator, there's a 2. Now again, you've got to be careful with all these negatives. You've got negative 4 times 1 times negative 12. First of all, what sign am I going to get here? positive. A negative times a negative is going to be positive. So plus 48. So it's 1 plus or minus the square root of 49 over 2. Now I really hope that you don't stop here. What else do you see that you think we can do? The 49. 49, square root of 49 is 7. So this is 1 plus or minus 7 over 2. Now just like we had to do when we're solving quadratic equations in the last section with the square root property, we have to be a little bit careful here. There's two solutions. Now if the numerator can simplify, I do want you to simplify. If it doesn't, you can just leave it as a plus or minus. But if it does, then do take the time to simplify it, please. 1 plus 7 is 8. 8 divided by 2 is 4. 1 minus 7 is negative 6. Negative 6 divided by 2 is negative 3. So there's your two solutions, 4 and negative 3. So there's kind of a nice example with the quadratic formula. Sometimes people memorize this using their favorite college fight song, or they rhyme it with "Pop goes the weasel," negative b plus or minus. Well, I'm not going there, but you need to have that memorized. Yes, sir.
So is it possible in the exam to keep the square roots with the decimals?
You might get one, but more often than not, I don't want you to simplify it down to a square root. We will go over, simplifying these things when you don't get a nice even root down here. And by that I mean trying to get a decimal value out of this. What is the decimal value? Here we got a nice integer value. But yeah, some of these, quite often, a lot of them would actually end up with decimal values. Now, let me point out one thing that you need to keep in mind. On an exam, I'm not going to tell you, oh, you have to do this one by the quadratic formula. You've got 4 different methods by which you can solve quadratic equations. If you gave me this problem and just said solve it, I'd factor this. I'd be like, okay, x minus 4, x plus 3, oh, x equals 4, x equals negative 3. Done. So why do we need the quadratic formula then? Well, we'll find out. Let's take a look at problem number 22. I'm going to write it with x's as opposed to t's, simply because t's and pluses are a little bit too close in my little modest attempt at writing. X squared equals x plus 4. Well, generally speaking, to solve our quadratic equations, unless you're using the square root property, you get 0 on one side to begin with. So what side should I put the 0 on? The right-hand side or the left-hand side? Yeah, the right-hand side. Let's keep the x squared term positive. So if I move these over to the left-hand side, change the sign. Perfect. So x squared minus x minus 4 equals 0. Your choice. You can factor it or you can use the quadratic formula. Which one are you going to do? Well, before you answer factor, can anyone see how this factors? Yeah, pretty badly. Yeah, nicely said. Yeah, it doesn't factor. There's no two numbers that multiply to negative 4 and add to negative 1. You're stuck. It just doesn't factor. So that's why we have the quadratic formula, is because sometimes you need to do something other than factoring and other than the square root property. A, B, and C. Micah, what would A, B, and C equal for this one? Let's start with A. So it's not really written, but what's understood to be in front of the x squared term? All right, so 1. Good. 1, -1, and -4. So take those and put them into the quadratic formula. Plus or minus the square root of something squared minus 4 times something all over 2a. Now when you write the quadratic formula for me, please make sure that this line goes all the way across and is underneath this term out in front. If you leave it dangling out there, it's really kind of wrong. So, I mean, some of you kind of interpret it the way you'd like to, and I understand that, but sometimes you make mistakes. So try and be careful to make sure that line goes all the way across. This should simplify somewhat nicely. I mean, down to at least one nice number underneath the radical. But you're not going to go any farther than the radical. You're going to kind of run into a little brick wall. The double negatives here become positive. 1 plus 16 over 2. Basically 1 plus or minus the square root of 17 over 2. And that's pretty much as far as you can go with this one. You can't go any farther. Earlier I promised that we'd work on finding some of the decimal values here. So let's find the decimal value for this. You have to do it one at a time. So take out your calculators and follow along. We'll do the positive one first, and then we'll do the negative one. So for the positive one, I'll show you two ways to do it. One that everyone can do, and one that if you've got a fancy up-to-date calculator you can do. Put parentheses around the numerator. So left parenthesis, and then 1 plus the square root of 17. Need a right arrow to exit the square root, depending on your calculator. Then a right parenthesis, because that's the whole numerator. And finally, divide by 2. If your calculator is the latest and greatest and up-to-date in its operating system, if you got a TI-84 or TI-84 Plus, you can do this. Hit the alpha key, then the y equals key. It'll let you type in a fraction in a more standard way. Now I don't necessarily need the parentheses like I had before. Either way you do it, you should get about 2.56. The cool thing about your graphing calculator is that once you've already typed this in, I can hit the second key, then the enter key. It'll pull up my last calculation. All I'm going to do is go up here and change that plus sign to a negative sign. And now I've got the negative root. So approximately speaking, this is about 2.56, call it 16, excuse me, 5616, and this is about negative 1.5616. Rounded to the nearest 10,000th place. Are you able to get that number off your calculators? Good? Good? All right. Let's do some more, unless there's something else on problem 22 that I can help out with. All right, let's try problem number 26 then. For w squared plus 1 equals negative 6w. Megan, what should I do to start this one? Perfect. Let's add 6w to both sides. That effectively is going to move it from the right-hand side to the left-hand side, where it changes signs like that. All right, cool. You should always check to see if these things factor. This is the difficult case of factoring a trinomial, where you multiply the outside numbers and see if that product, if you can find two numbers that multiply to 4 and add to 6. In this case, you can't. So this one won't factor. If it won't factor, you don't have a lot of choices. You could use completing the square, but I'm not a really big fan of that one. Not that it's wrong. You can still get them right. But let's practice the quadratic formula, which is really the point of this section. 4, 6, and 1 are your A, B, and C. Uh-oh. No, okay, this one should work out all right. So let's take a look. It's going to be x is, actually I should write w is the negative of something plus or minus something squared, 4 times a times c over 2 times a. Fill in the formula, see what you can come up with for w. Should end up with something kind of similar to the last one, in as much as it'll be, plus or minus some radical number. Okay, so let's finish this up. We've got negative of b, which is negative of 6, plus or minus b squared, which is again 6, so 6 squared, minus 4 times a, which is 4, times c, which is 1, divided by 2 times a. How does that simplify? Well, negative 6 plus or minus the square root of 36 minus 16 over 8. Like that. And that's not bad. If you got that far, that's good. All right. But there is some more that we're going to need to do here. Before I discuss that, are we okay with what we have up to this point? So let's keep working and split up the 20 there. How could you split up the 20? What two perfect, or what numbers multiply to 20 such that one of them is on that list of perfect squares we have on the left-hand side board? 5 and 4. So I'll put the 4 here and the 5 here, and that can simplify a little bit. So we get negative 6 plus or minus 2 square roots of 5 over 8. It's really tempting, and I know it, I understand it, but please fight it. It's really tempting to say, oh, look, hey, I can cancel the 2 and the 8, or the 6 and the 8. Not really. These terms are joined in a mathematical union. They're adding and subtracting each other. You can't cancel into the parentheses. But what you can do is you can factor something out. Sydney, is there a greatest common factor here between these two terms? Something that's in common to both of these I can factor out? A 2. If I factor out a 2, that leaves behind a negative 3. And here I'm left with just plus or minus the square root of 5. Check it by distributing. If you distribute the 2, I get negative 6 plus or minus 2 square roots of 5. So those two things are equivalent. Does this help me out at all in terms of simplifying this? Good? Yes. Now we can finish the cancellation with the 2 and the 8. So 2 goes into 2 once and into 8 4 times. So the final answer here is negative 3 plus or minus the square root of 5 over 4. That's what you're going to see in the back of the book. Okay, that one's a long one. Getting here isn't bad. Getting here is all the marbles. So, any thoughts, or can I help out in any way to get you from here to here? Let's practice some more then. Problem number 28. Three y squared equals 12y minus 4. Victoria, what should I do to start? It's a 12y, yes. Good. So we're going to move these both to the other side. 3y squared minus 12y plus 4 equals 0. You can try factoring. 3 times 4 is 12, but I don't think there's any two numbers that multiply to that 12 and add to negative 12. Pretty sure there's not. So if there's not, then one alternative we have is the quadratic formula. 3, negative 12, and 4. Boy, that negative b keeps on coming up. It's very easy to lose track of that unless you're being careful with your parentheses. So y is going to equal the negative of b plus or minus the square root of b squared minus 4 times a times C over 2 times A. Carefully plug all these things into your formula. Negative of negative 12 plus or minus the square root of negative 12 squared minus 4 times A, which is 3, times C, which is 4, over 2 times A. The part that I most want you to come up with, though, is this last part right here. Once you've simplified it down to something plus or minus the square root of a number, break that number up and get that cancellation with the denominator. So, again, I'm going to kind of pause it, let you finish simplifying it, see what you can come up with. Take out your calculator and find out which one of those numbers on the left-hand side board evenly divides maybe 96. It is. Start with 96 is here. Start with 81 and work your way down the list. That way, the first one you find that divides it is the largest one that divides it. So you can get this done in one step. The second one doesn't matter. The first one wants to be a number on that list. Okay, double negative here becomes a positive, so I end up with 12 plus or minus the square root of 144 minus 48 over 6. That can continue to simplify. 12 plus or minus the square root of 96 over 6. Now the idea here with the square root of 96 is to break it up as a perfect square times, whatever else. So here's what you do. Or at least you can look at the left-hand side board and see your list of the perfect squares. Since 96 fits in right here, work your way up the list. Now, regrettably for us in this example, it might take a little while. That's all right. 96 divided by 81, not an even number. 96 divided by 64, again, not an even number. So we'll keep on doing that until we hit pay dirt, or until we get down to 1. So none of these are working out nice and even. 96 divided by 25, well, I think I can see 25 doesn't go in there, so let's skip up to 16. 96 divided by 16, bingo, goes in evenly. So it took a little while, but we finally got there. 96 is 16 times 6. Are we okay with that step? That's a big part of finishing this up here. 12 plus or minus 4 square roots of 6 over 6. And let's see here. There's a 4 that's part of a greatest common factor in the numerator. Jackie, if I take out the 4 in the numerator, what's left? Good. Now 4 and 6 don't exactly completely cancel each other out, do they? Thanks, Jackie. But we can get a little bit of simplification. 2 goes into 4 twice and into 6 3 times. So I'll give you a couple different possibilities for the final answer. You can just leave it like this, and there's nothing wrong with that as far as I'm concerned. 2 times 3 plus or minus the square root of 6 over 3. Or you could distribute it. You can do 6 plus or minus 2 square roots of 6 over 3. Either one of those is fine. The big thing is to finish up with that extra cancellation and simplifying the radical here. How are we looking on problem number 28? Okay there? Tell you what, let's take a bit of a break from this with the next two problems. The next two problems, the goal is to try and make them a little bit easier to work with as far as putting them into the quadratic formula is concerned. We'll start with problem number 38. So for 38a, the equation is 1 over 8 squared. It's going to be 1 over 8x squared, I should say, plus 1/2 x minus 3/4 equals 0. So what would A, B, and C equal for something like this? George? Mm-hmm. Mm-hmm. Does it look like it would be a lot of fun to plug that into the quadratic formula? You sure? You can try. You don't have to take my word on it. You can try it for yourself and find out if it's fun. No? No takers. Okay. Well, what we can do is we can multiply the whole equation by the lowest common denominator. What's the lowest common denominator for all these fractions? 8. So all these expressions get multiplied by 8. 8 times 1/8 is just 1. So x squared. What's 8 times 1/2? 4. So I get 4x. Now, the 8 times -3/4, maybe you're not really keen on that one. I understand that one. That's fine. Let's just do the 8 times the 3/4 here. You can think of that as 8 over 1 times 3 over 4. I hope you do some simplification. 4 goes into 4 once and into 8 twice. So I'm left with 6 up here. X squared minus, or x squared plus 4x minus 6 equals 0. Nice. That's all they wanted in this, is to make it a more manageable equation. There's a couple other examples like that. Let's do the next part, part B. 33y squared plus 99y minus 66 equals 0. Wow. Hey, want to try putting that one in the quadratic formula? Maybe not as it stands. Maybe we can do a little bit better. Does anything catch your attention about all three of these numbers? They're all divisible by 33, right? So what if I divided this side and this side by 33? And being the very conscientious and thoughtful instructor that I am, I'll help you out on the right-hand side. We get 0. On the left-hand side, this 33 really divides all these terms. 33y squared over 33 plus 99y over 33 minus 66 over 33. What do I end up with? Y squared plus 3y minus 2 equals 0. And again, that's it. All they're looking for you to do here is to rewrite your equations to simplify them if you had to put it in the quadratic formula. By the way, would this one factor? Not quite. If this was a plus, it would factor. But there's no two numbers that multiply to -2 and add to 3. So you're stuck. You'd have to use a quadratic formula or something else, but not factoring. Two more kind of like this. Problem number 40. 0.6 a. I'm going to write a as opposed to t. A squared minus 0.1 a minus 0.2 equals 0. This doesn't look much more appealing than problem 38a when we had all those ugly fractions. So again, you want to do something to kind of clean this up. What can I do in this case so that it's not so ugly, not so bad? Multiply everything by 10. Perfect. Ruben, you're the first one to spot that, so let me maybe ask you, what equation is going to pop out of here when I multiply everything by 10? Perfect. 6a squared minus a minus 2 equals 0. Okay. This one I think actually would factor if you did try and factor that one. Thanks again, Ruben. So that's part A. Part B, negative a squared minus 15a plus 12 equals 0. There's not a lot that's bad about this one, but generally speaking, it's a little bit annoying to have a negative with a for your leading coefficient. So that's really the only thing that I could see that they would want cleaned up here. How could I get rid of that negative Yeah, you could move everything to the other side. What else can we do? Multiply by -1 or divide by -1. They're all going to work out to the same. Dividing by -1 and multiplying by -1 give you the same result. So let's just divide everything by -1. -1, -1, -1, -1. The right-hand side is still 0. The left-hand side, everything changes sign. A squared plus 15a minus 12 equals 0. Nice. So kind of a little break here from some of the tedium of the other action. Yes, sir. No. Quadratic formula will always work for any quadratic equation that you can put into this form. Ax squared plus bx plus c equals 0. If you can put in this formula, in this form, quadratic formula will always work. Always, always, always. That's the nice thing about the quadratic formula, is that it always works. But what you want to keep in mind is that you don't want to turn to the quadratic formula first, as this example shows. If it factors, factor it. If it doesn't, then you use the quadratic formula. That's the way I look at it. So I have seen people, and they've been successful in it, use the quadratic formula for everything. I just feel bad for it when they have some simple problems that could factor. It's going to take them a lot more time. So the good thing about the quadratic formula is that it always works. The bad thing is that it's tedious, and you can make mistakes with it. So let's get back to using the quadratic formula then. Problem number 46. Is that a -16 out in front of that thing? Yes. All right. So -16 x squared minus 16x minus 3 equals 0. Any suggestions before we even get started doing anything on this problem? Yeah, let's multiply everything by -1. So I'm just going to put parentheses around this, and we're going to multiply everything by -1 just to clean it up. It's going to be a lot friendlier to work with this if we have all positive numbers as opposed to all negative numbers. You could make it work with the all negative numbers, but chances are it's going to be a lot easier to make a mistake. Okay, I'll let you take it from here. Okay, so let's look at this one together. We want to solve this quadratic equation. It's going to factor as 4x plus 3 times 4x plus 1 equals 0. Set each term equal to 0. So 4x plus 3 equals 0 when 4x equals negative 3 or x equals negative 3/4. Likewise over here, x equals negative 1/4. Oh, I'm sorry. Did you guys use the quadratic formula on this one? Oh, my bad. All right. So I'm teasing you a little bit. All right. This is just a reminder that you can solve these any way you want. And if it factors, hey, factor it. You don't get extra points by slugging through the quadratic formula. Solve it the easiest way that you can, the easiest way that's comfortable for you. Now, in case you're wondering, oh, how did you know that? All right, here's the way we did it back when we were working on this stuff a couple chapters ago. You look for two numbers that multiply to 48. So the 48 is the product of the outside numbers. Two numbers that multiply to 48 and add to 16. That 16 is your middle number. If you split it up into 12 and 4, then we can make some progress. That 16 splits up like this. You can factor out by grouping from here now. So there's a 4x that's common to this. There's nothing that's common here, so what I tend to recommend is factoring out a 1 as just like a placeholder. After that, 4x plus 3 is a common factor. Factor out the 4x plus 3, and then you've got your factorization. And then it's set each term equal to 0 and solve. Now, a lot of people aren't really good at that kind of factorization. You know, and if that's you, then you're just like your instructor was when I was taking this class. I was terrible at factoring these things. In fact, I was so bad that when it came to giving me a test and all they had to do was like factor these things, I'd work the quadratic formula, get the two answers, and then work it backwards to get the factorization. I was that bad at factoring these kinds of problems. So I have, you have my sympathy. You really do. As far as problem 46 is concerned, the way that most of you probably attacked it, A is 16, B is 16, C is 3. If you're using the quadratic formula, no problem. Let's just run through it and get x is the negative of 16 plus or minus the square root of 16 squared minus 4 times 16 times 3 over 2 times a, or 2 times 16. So it's negative 16 plus or minus the square root of 256 minus, that's what, 192? 192 divided by 32. Or negative 16 plus or minus the square root of 64 over 32. And that works out pretty nice because square root of 64 is even. Now, if you get to this point in a quadratic equation problem where you're taking the square root of something and it works out nice and even, that's telling you that it could have factored. So, okay, you missed the factorization, no big deal. Now, a lot of you, and I was proud of that, it was amazingly conscientious, you factored out the 8, which is your GCF, and that's great. But 16 and 8 are both integers, so we can combine them. I'm not going to bother to factor out the GCF and cancel it with the denominator. I'm just going to do the positive case. Negative 16 plus 8 is negative 8. Over 32 reduces to negative 1/4. Negative 16 minus 8 is negative 24. Over 32, 8 goes into both of these, in the numerator 3 times, and the denominator 4 times. So there's your two answers arrived at in a different way. Now, what works for you? That's kind of an individual decision. It's like whatever you like the best. Whatever you see, whatever's easiest for you. One thing that I will guarantee you is on the exam, you will have to use the quadratic formula at some point. I'm not covering it just for fun so that I can give you problems that you use the square root property and factor for. You need to make sure that you can do the quadratic formula. Have it memorized, etc. How are we looking on 46? Yes.
What if the answer was decimals? Is that fine?
I don't want decimals. I'll either ask for it in fractions or just leave it with the radicals. I may ask for one that you give me the decimal for this number. In fact, you're giving me a good idea. I might just give you an expression like that and say calculate the decimal answer. But generally, I want either fractions, expressions with radicals, etc. Something like this. I'm typically not going to want the decimal answer. Okay, problem number 50. Negative x squared minus 6x minus 2 equals 0. Jenna, suggestions to start out with on this one? Sure. Let's multiply through by negative 1 and just clean up some of the negatives here. So that gives us x squared plus 6x plus 2 equals 0. Now, one of the lessons for the last problem was that if you can factor, look for the factorization. I don't spend too much time looking for the factorization. If I see it, great. If I don't see it right away, just bail out and use a quadratic formula. I think the effort spent factoring, it can be faster, but then you can try and factor something and find out, oh, gee, it doesn't factor. And then you have to use a quadratic formula. So don't spend too much time trying to factor. In this case, it should be pretty clear. Will this factor? No. So you have to use a quadratic formula. Yes, sir?
So the formula is going to work always.
Quadratic formula always works. If you wanted to use it to solve every single problem, you could. You can even use it to solve problems like this. X squared minus 7x equals 0. Now, I hope you don't solve it with the quadratic formula, but you could. What you should do is say, all right, that's x times x minus 7 equals 0. X equals 0 or x equals 7. To do the quadratic formula here, you'd have to realize that there's a 0 that's kind of hidden here. So you'd have a equals 1, b equals negative 7, c equals 0. But you could do the quadratic formula for that one. I mean, it'd be like burning down a house to roast a pig, but you could do it. All right. I'm glad you found that one funny. Everyone else was busy on that one. it's stuck with you. It's stuck with you. So, yeah, the pop the weasel thing, There's all kinds of stuff online. If you Google, there's like the quad song. They had like a whole high school in on this, and they made some song. It's pretty cool. Anyways, negative b would be the negative of, oh, excuse me, we've got to look over here. Negative of 6 plus or minus 6 squared minus 4 times 1 times c, which is 2, over 2 times 1. So negative 6 plus or minus the square root of 36 minus 8 over 2. Negative 6 plus or minus the square root of 28 over 2. And that's pretty good. That'll get you, maybe three or 4 points out of 7. But there's a little bit more we need to do here. Square root of 28 can be broken up. How would you split up 28? Good, 4 and 7. So it's negative 6 plus or minus 2 square roots of 7 over 2. And something special happens when we do this one. If you factor out the 2, you're left with negative 3 plus or minus the square root of 7 over 2. And wow, those cancel. Completely get rid of that denominator. You're left with negative 3 plus or minus the square root of 7. Yay. How are we looking on these? Pretty good. Should we do one more that asks you to pull together all these things? Well, no, it's not. The problem with 2 and 14, if I did this as negative 6 plus or minus the square root of 2 and the square root of 14, what's the square root of 2? Square root of 14? 3 something, I don't know. Neither of these are a perfect square. You can't get rid of the square roots by saying, oh, I know what the square root of this is. I know what the square root of 4 is. I don't know what the square root of 2 is. I don't know what the square root of 14 is. So this first number here has to be one of your perfect squares. Has to come from this list. Okay? Anything else on this one? This is as far as I'd like you to go. I could ask you for decimal values if I wanted, but honestly, this is where I want you to get to. Okay? Okay. Problem number... Excuse me here. Problem 58. We can get this one. This can be our last one. $120b squared plus 120b minus 40 equals 0. Let's at least start this together. Sabrina, what would you do to start?
The formula.
Take out a 40.
Yeah, I'd start by dividing everything through by 40. Absolutely. So 3b squared plus 3b minus 1 equals 0. That looks a lot more manageable. And from here, it's just a matter of running through the quadratic formula. You can run the quadratic formula with a equal 120, b equal 120, and c equal negative 40, and work from there. Yeah, I think I'm going to do a lot less work by doing it with this one. So, it's up to you. I think I'd recommend this second course of action, though. course. Yes. Well, at minus and then parentheses, it's going to be negative 12. That's as far as, there's no perfect squares to go into, so that's it. That's as far as you can go. Yes. Square root of 14, square root of 1,000. But neither of those is a perfect square, so as far as you can go. Okay, so 3 squared is 9. Negative 4 times 3 times negative 1 is going to give you, well, if you're subtracting, you're going to subtract a negative 12, or you can just say, I've got two negatives here, it's going to be a positive. Either way, you'll end up with 9 plus 12 is 21. Now, as far as doing something from here, 21 fits right between 16 and 25. And if you work your way up this list, none of these numbers other than 1, which doesn't make a difference, none of these numbers evenly divides 21. So that's it. That's as far as you can go with problem number 50 here. Or no, not 50, 58. Do you want to practice calculating the decimal value for this one last time? No, you're good. All right. Let me give you some homework then. For homework, try problems. Let's see. 13 through 27, and I gotta say "and" real quickly because otherwise people start closing books and things like that. 37 through 53, and just 73A, 73 and 75, just part A. All right. Good luck on those.